Okay, 0625, paper 1-2, October-November 2024. Number 1, a student measures the volume of 3 liquids using 3 different measuring cylinders. The table shows the volume recorded by the student. So in the first measuring cylinder, each division is 0.1 cm cube. So the point where the lower meniscus is showing is 1.2 cm cube, and for number 2, each division is 0.2 cm cube, and the lower meniscus is here, so its volume is 2.4. So number 1 is matching with the one that they gave, but number 2 is not matching, so this is wrong. Number 3, each division is 2 cm cube, and the lower meniscus is in the middle between the division, so it means there's 1 cm cube here. So if you count up to here is 24 and plus 1, 25, so the total volume is 25 cm cube, so the third one is also right. Which readings are correctly recorded? 1 and 3 only, so answer is C. Number 2, the diagram shows the speed of a falling object changes with time. Which rule describes the motion of the object between x and y and between y and z? So between x and y, it is still accelerating because of this little curve, but the only thing is that the amount of acceleration is decreasing, but it doesn't mean that it's not accelerating. So between x and y, it is accelerating, but for y and z, there is no gradient, so it means that the acceleration is 0, so the speed should be constant, and the answer should be B. Number 3, the speed-time graph represents a journey. How does the graph show that the distance traveled in section X of the journey is greater than the distance traveled in section Y? So this is section X, and this is section Y. We have to keep in mind that the distance is the area in a speed-time graph, so the explanation for having more distance traveled in X suggests that the area in X is greater than area in Y. So the first answer that they gave matches the explanation, so answer is A. B is wrong because the gradient would mean the acceleration. C is wrong because the speed at the end of section X, which is this part, and the speed at the end of section Y are not the same. That doesn't necessarily say anything about the distance. So C cannot be used to determine or explain what is being asked. Number D, the time for section X is greater than the time for section Y. The time can be greater, but if the area is small, it doesn't really lead to the more distance traveled. So D is also wrong. Only answer should be A. Number 4, which rule contains 2 correct statements about the mass and the weight of an object? So let's read through this. Mass of an object is measured using a measuring cylinder. This is wrong because you use a measuring cylinder to measure the volume. Is the gravitational force exerted on the object? This is the weight. This means the weight, so it's also wrong. Mass is not the same as the weight. Mass of an object is measured in newtons. No, it's usually grams, kilograms. So C is also wrong. It's the same everywhere. So the mass is constant. This is correct. continuing with that, the weight of an object can vary from place to place. This is also correct because your weight on Earth is not the same as your weight on Mars, but the mass is the same. So answer for number 4 is D. Number 5, which equipment is used to find the density of an irregularly shaped stone? So force meter and ruler. You don't use this to find density because density is, as you remember, mass divided by volume. So you need an equipment to find the mass and an equipment to find the volume. So A does not fit this. Number B, measuring cylinder, ruler, and water. You can really use the ruler to find the mass. So B is also wrong. Number C, measuring cylinder, top hand balance, and water. This is correct because you use the measuring cylinder and the water to find the volume of the irregularly shaped stone and the top hand balance to get the mass. So for number 5, C is the answer. Number 6, the diagram shows a force F acting on 90 degrees at a bar at a distance D from the pivot P. So the image already shows what they described. Which pair of changes causes the greatest increase in the moment of the force F about the point P? So they want the greatest increase in the moment. So to increase moment, you can make the force go to left side, to the right, and you can also increase the force. So instead of just F, you can make it 2F, 3F, something. So the answer A is halving and halving D. This will make it decrease, so A is wrong. B, halving F and doubling D. This would just cancel out, so this is also wrong. It would still give the same moment. Doubling and halving D, same thing as B. This is also wrong. Doubling F and doubling D, this is correct, so it's D. Number 7, a child of weight 420 Newton is sitting on a swing with her feet on the ground. Child experiences an upward force from the ground of 130 Newton and an upward force from the swing of 290 Newton. What is the resultant force on the child? So if this is the child, its weight is going down, but it's also experiencing an upward force, 130, and another one of 290. So if we subtract these two forces from its weight, then you would get 0. So the resultant force on the child is 0. So the correct answer is A. 8. A builder lifts one concrete block from the ground onto a platform. So it's going up. The weight of one block is 170 Newton. So, okay, what is the useful work done against gravity on one block? So we know that gravitational potential energy is the same as mass into gravity into height, or you can just say weight into height. Since we already know the weight of one block, which is 170, we use that and multiply with the vertical height. We don't use 2.6 because it's going diagonally. It's not the difference in the lowest point and the highest point. So 2.1 is the same thing as the lowest and the highest difference, not 2.6. So we use 2.1 and we multiply those two and we'll get 357 joules, and if we round it, it's about 360 joules. Reason it's joules is because this is energy and not power. C and D gave the unit for power, which is watt. So these two are wrong. And between these two, it should be 360. So the correct option is A. Number 9, students are asked for examples of water being used to store energy. 3 examples are listed. Energy stored in waterways, energy stored in tides, energy stored in water behind dams. So for number 1, this is correct because waves have energy. Wave transfer energy. So 1 is correct. And for number 2, energy is stored in tides. This is also correct because during high tide, it gains some gravitational potential energy, and at low tide, there's less gravitational potential energy. So 2 is also correct. 3, energy stored water behind dams. This is the mechanism that we use to generate electricity. So all 3 of them are correct. So the correct option is A for number 9. Number 10, which statements about power is correct? Okay, so power is measured in joules. This is wrong. It should be in watts. Power is equal to energy into time. This is not into, it should be divided. So B is also wrong. Power is the rate of energy transfer. So rate of energy transfer means energy divided by time. So 10, number C is correct. So C is the answer. 11, in which position does a person exert least pressure on the ground? Okay, so pressure is force over area. So if the area is the largest, then the pressure should be the least. Kneeling on the ground, lying flat on the ground, sitting on the ground, standing on the ground. In all of these options, lying flat gives the most area, so it should be B. So 11 is B. 12, which name is given to the change of state when steam is at 100 degrees, changes to water at 100 degrees? So at 100 degrees mean the water is boiling, or yeah, the water is boiling, but they said the change of state when steam changes to water, so it means that it's condensation. So B is correct. 13, a fixed mass of air is trapped inside a cylinder fitted with a movable piston. The piston is slowly pushed in. So this part is going to move to the left. So after some time, it should become like the picture that I drew here. What happens to the pressure and the volume of the trapped air? So we want to know what happens here. This from before and to after. So the pressure and the volume are inversely related. So if the volume decreases, the pressure should increase. Since we move the piston to the left, the space is less after we push it, so the volume should decrease. So volume decrease, and then since they're inversely related, pressure should increase. So the correct option for question 13 is C. Number 14, the diagram shows electricity cables being put up on a warm day. The cables are suspended between the supporting pylons as shown. Why are the cables not tightened to make them higher above the ground? So in this question, they're asking why we don't, so between these two pylons, we put it like this. They're asking why we don't have it a little higher like this. they're asking about the expansion and the expansion of a material based on the temperature. So when it's colder, it will contract up. So that means, like, since it's on a warm day, it's gonna be a little bit drooping down, but if it's on a cold day, it'll go back up. So because of the cold days, we don't make the cables go up more, because it would mean that if it's too high up, then the cable will be stretched straight like this, which is not good. So yeah, because it's on a warm day, you let it sag a little, and on a cold day it will go back up. So they will contract on cold days is the correct explanation. So 14 is A. For number B, the option B is wrong, because on warm days it will expand. So B is automatically wrong. They will expand on cold days is also wrong, because they should contract on the cold days. And number D is correct. They will expand on very warm days, but they're asking why the cable isn't tightened more so that it's higher up. So this is not explaining what is being asked. So 14D is wrong, but A is correct. 15. Which diagram shows the overall movement of particles and the temperature change when a liquid evaporates? So when a liquid evaporates, the molecules with the highest energy is leaving the liquid from the surface. So which means that the liquid that gets left behind gets colder. So in all the options, only A and D has liquid cooling down. So we can choose between A and D. Particles have to leave the liquid. So D is wrong now. So the correct option for question 15 is A. 16. There is a vacuum between the double walls of a vacuum flask. So something like this. Which type of thermal transfer are reduced by the vacuum? So by having a vacuum between the two walls, the energy from here cannot be conducted, or through convection they cannot be transferred. So conduction and convection is reduced by having the vacuum. So B is the correct answer. Radiation, you can't really stop it, because it's an electromagnetic wave that's leaving, basically the infrared radiation. It can travel through vacuum, because it can also travel through space. So you remove the options with radiation, and you'll still be left with option B. So 16 is B. 17. The diagram shows a transverse wave. Which distance is equal to one wavelength? So one wavelength is when the distance between adjacent troughs or adjacent crest, like from here to here, or like not that, from here to here, or like something if it continues here to here. But they didn't give those pictures or thing. They gave us with the number and just a half, 1.5 wave. So the distance for one wavelength should go to here. Why? Because if it's from 1 to 2, it's just half of a wave, and that is, wavelength is supposed to mean one complete wave, so you can have a half wave. So the points between 1 to 3 is one wavelength, so B is the correct choice, 1 and 3. The easy method to remember this is the sine graph. One complete wave in the sine graph looks like this, like S. For a cos graph, like this. But this is the same thing as what I just said at first, like crest or trough. So number 17, the correct answer is B. 18, the diagram shows a wave before it reflects from a barrier. Which label section from the diagram represents a wavefront? So wavefront is like the wave that you can see in a ripple tank when you let the water move, like you can see like the shadows a little bit like that. Those are the wavefronts. So option A, this is showing the arrow is the direction of the wave traveling, so it's not the wavefront, is wrong. B is the distance between two of the highest points. So this means B is the wavelength, lambda, so B is also wrong. For C, it's pointing to one of these vertical lines, which is a wavefront, because this is from the upper view, but if you move it to the side, it looks like this. And the wavefront is basically these parts. These are the wavefronts, one at the top that we see. So C is the correct answer, because when we drew it, it's like this. So this is the top view, and this is the side view. Just top view and side view. So 18 is C. C is the correct answer. D is just showing the barrier, so D is just wrong. Number 19, the diagram shows a ray of light as it passes from air into glass. So air is down here, glass is up here. Which row shows the angle of refraction and the normal? So angle of refraction is always taken from this normal line, like this. So P is angle of refraction, and then the normal is like between the two mediums is like the perpendicular line, so the normal line should be R. They labeled it R already, so R is the answer. S is just the incident ray, the refractive ray. This is the incident ray, and then this is the refracted ray. So 19, the correct option is A. 20, the diagram shows rays of light passing through converging lens. Which labeled arrow represents the focal length of the lens? So the focal length is like the total length from the center to the converging point of the converging lens. So the one that's showing these two, the distance between these two points is D. So the focal length of the lens is represented by D, option D. So correct answer is for 20 is D. 21. The diagram shows a narrow beam of white light being dispersed by a glass prism to produce the visible spectrum. Which statement describes what happens to the frequency and wavelength of the light in observing from P to Q across the spectrum? So P should be red and Q should be something that's not red, like let's just say violet. So the frequency from red to violet is increasing, but as we know, frequency and wavelength are inversely proportional, so the lambda or wavelength also should decrease since the frequency is increasing and the speed is constant. So in all of the options, the frequency increases but the wavelength decreases. Answer is D. 21. The correct option is D. It is wrong because if they both increase, then the speed will change, so that it does not happen. Same as well for B. C, the frequency decreases but the wavelength increases. It's going from violet to red. So C is correct, but it does not explain or describe what happens when it's going from P to Q or red to violet. So C is wrong because it's in reverse. 22. The early universe was filled with gamma radiation. Since then, the radiation has shifted to the microwave region of the electromagnetic spectrum. How has this change affected the wavelength and speed of the radiation? So, the radiation going to microwave is called redshift. This phenomena is known as redshift. Basically, the wavelength of the initial wave is increasing and making the radiation go towards the left side. So if we remember the order, which is radio wave, microwave, and then IR, light, visible light, and then UV, X-ray, and then gamma ray. Redshift makes the wave go towards the radio wave side. So basically the frequency is decreasing, and since the frequency decreases, the wavelength should increase. So the one that matches this description is wavelength increasing and speed is staying the same, because the increasing and the decreasing will cancel each other out and the speed will remain the same. So 22 is D. Or one way you can remember for the speed staying the same is that EM waves always have a speed of 3 into 10 power 8 meters per second. So this does not change no matter which part of the wave you're in, whether you're in gamma, radio, IR. The speed of the EM wave is the same. So that's another way to remember it. So 22 is D. 23. Sound waves may cause an echo. What happens to sound waves to cause an echo, and what is the nature of the sound waves? So sound waves get reflected to cause an echo. So someone will scream at a wall, like when they scream at a wall, the initial waves go like this, and then it hits the wall, and then it comes back like this, which causes an echo. So echo is caused by reflection of the sound wave, and for the nature of the sound waves, you have to know that it is longitudinal because there's compression and then rarefaction and then compression, rarefaction, which is only found in longitudinal waves. For transverse, they have two waves that are going perpendicular to each other like this. That is transverse waves. So sound is an example of longitudinal waves, so the nature should be longitudinal. 23, the correct answer is A. 24, the diagram shows what happens when a bar PQ is brought near a permanent magnet which is standing on the balance. So we can see that the weight, the reading on the scale is increasing when PQ is being brought towards the magnet. So what could bar PQ be? An iron bar or permanent magnet with P and N pole. So if it's an iron bar, it wouldn't cause the pen reading to be increasing. So the iron bar is already wrong. It would basically attract the permanent magnet upwards, making the reading decrease. So A, B, and C are all wrong because they contain iron bar. So PQ can only be a permanent magnet that is pushing down or repelling the permanent magnet and causing the weight, causing a force. So the scale reading is like increased. So 24, answer is D. 25, direct current can be represented on a voltage time graph. Which graph shows the correct waveform for a DC supply? So in a DC supply, the voltage does not change. It's remaining the same constant throughout the entire circuit, the entire time. So for 25, answer is D. It's very straightforward. The voltage does not change. It does not go up, it does not go down. 26, a resistor with a potential difference PD of 100 volts across it carries a current of 5 milliamps. What is the resistance of the resistor? So R is equal to V by I. That is the formula. And then voltage is given in the base unit, so 100. But for current, it's given with milli. So for milli, if we convert it to normally amps, we divide 5 by 1000. So to get R, we divide 100 with 5 by 1000 and you'll get D, 20,000 ohms. 26 is D. And for 27, the diagram shows the information label on an electric kettle. What is the value of the current when the kettle is heating water? So they want the current and they gave us the power and the voltage. So P is equal to VI, and to find I, we divide the power with the voltage. So 1,500 divided by 110, or you can simplify it to this. And then if you find the decimal value, you'll get 13.67, which you can round up to 14 amps. You don't need the frequency because this is just showing that the voltage is changing sides at 50 hertz. Basically, it's just an alternating current, so the voltage is changing directions every few seconds, or more like multiple times a second. So 27 is D. You don't need the frequency. This is just extra stuff. For number 28, which circuit enables the resistance of the thermistor to be determined? So to determine the resistance of the resistor, R is equal to VI. Using this equation, we know that we need the voltage and the current. So to find the voltage, you have to connect a voltmeter across the thermistor because you want the resistance of the thermistor. So B is wrong. A is also wrong because you don't connect the ammeter in parallel like this. So A and B is already wrong. Between C and D, C has the voltmeter across the thermistor while D has the voltmeter across the variable resistor. Since they're asking for the thermistor, you should put it on the voltmeter like I've said before. So C is the correct answer. 28 is C. 29. A student makes a battery by connecting 5 cells as shown. So what is the EMF of the battery? We can see that this is connected in series and some of them are connected the wrong way. Basically this one and this one. The rest are in the same direction. So we have to subtract the EMF of these two batteries from the entire total. So if we just do 2.5 minus 2 minus 1.5 plus 2.5 plus 2, you'll get 3.5 volts. So 29 is C. C is the correct answer. The diagram shows the safety label on an electric oven. Oven is connected to a mains electric circuit. A fuse is placed in the circuit to protect the cabling and prevent overheating if there is a fault. Where should the fuse be placed and which rating should the fuse have? So the position of the fuse should be on the live wire because on the neutral wire it isn't connected to the electric circuit. So you don't use the neutral wire. Usually you just put it on the live wire, which connects the electric oven to the mains electric circuit. That is why. For the fuse rating, it should be more than 10.1 because if it's less than 10.1 or the same as 10.1, it will just keep the fuse will keep blowing up and disconnecting the circuit, so you won't be able to use the oven. That's why you need a larger fuse rating than the one that they are using in the appliance. So for 30, it should be B. B is the correct answer. 31. A straight wire is stationary between the poles of a magnet. It lies perpendicular to the magnetic field, which action does not induce an EMF in the wire. So we do not want an EMF. Not induce an EMF. To produce an EMF, we have to make the wire cut the magnetic field between the poles. So to cut it, you just move it up or down the wire. And the EMF depends on the speed at which the wire cuts the magnetic field. So that is something to note about the EMF. But to not produce an EMF means the wire does not cut the magnetic field. So let's read through this. Moving the magnet up towards the top of the page and the wire down towards the bottom of the page. So the magnet is moving up and the wire is moving down, which means the electric field is getting cut, so it induces an EMF. Moving the magnet upwards to the top page only, still again the wire is still cutting the magnetic field since it's going up and the wire just stays still. So B is also wrong. C, moving the wire and the magnet up towards the top of the page at the same speed. So the entire setup is just moving up at the same speed. So C is correct because you won't cut the magnetic field if you move both of them at the same time with the same speed. It's just going to just go up. So C is the correct answer. D is wrong because you move the wire down, you're gonna cut the magnetic field. So D is wrong. So 31, EMF is not induced in option C. 32, the diagram shows a wire hanging vertically between the poles of a magnet. There's a current in the wire in the direction shown, so it's going up. The wire moves into the plane of the page away from the observer. In which direction does the wire move when the current is reversed? So when current reverses, the direction should also reverse. So if it's going into the page, it should come out of the page. If it's moving to the top of the page, it should go down the page if the current is reversed. So option A, the wire moves into the plane of the page away from the observer. That is the same as the first, so the current is not reversed here. Wire moves to the left, wire moves to the right. That does not mean that the current is reversed. It actually doesn't even do anything. So 32, D is the correct answer because, like I said, the direction is completely opposite. It went from going into the page to out of the page. So 32, the correct answer is D. 33, a current carrying coil in a magnetic field experiences a turning effect. Students are asked how the turning effect can be increased. 3 suggestions are listed. 1. Decreasing the number of turns on the coil. 2. Increasing the current. 3. Increasing the strength of the magnetic field. Which suggestions will increase the turning effect? So the turning effect depends on how much EMF is being produced. So number 1, decreasing the number of turns on the coil. This decreases the turning effect because there's like less EMF being produced. And for number 2, increasing the current, yes, that will increase the amount of EMF produced. 3, increasing the strength of the magnetic field. This also increases the EMF produced. So 2 and 3 is the correct choices or suggestions to increase the turning effect. So 2 and 3 only. Option D is correct for 33. 34. The student suggests 3 sources of naturally occurring background radiation. 1. Cosmic rays. 2. Medical X-rays. 3. Radio emissions from radon gas from the ground. Which suggestions are correct? So they said naturally occurring background radiation. The only thing that's natural is cosmic ray and the radioactive emission from radon gas from the ground. So 34 is A, 1 and 3. 35, the student measures the rate at which ionizing radiation is emitted from a radioactive substance. He places a detector at different distances from the radioactive source. The table shows how the count rate from the source varies with distance D. So when the detector is touching the source, it has the maximum count per minute, count rate. When it's a little bit further away, 2 centimeters further, it's a lot lower, 115, and at 4 centimeters is 0. So we can conclude that it is an alpha particle because alpha particles can move 3 to 7 cm in the air. Beta is like 20 centimeters to 3 meters, which is like a lot more than what is being given. So A is the correct answer, alpha particles. For gamma rays, it's going to go infinitely far because it is an EM wave. And for D, EM wave. For the X-ray is not even a radioactive particle or emitted from radioactive source. So D is like already a no choice. Gamma rays, it's infinite in air only. I'll add this in air. It gets stopped by a thick lead wall. So 35 is A. 36, radioactive decay results in the emission of alpha particles, beta particles, and gamma radiation. Which types of emission result in the nucleus changing to that of a different element? So alpha and particle both changes the element, but gamma does not, because gamma is just energy being radiated out. So 36 is A. Alpha and beta particle emission. 37. The radioactive isotope has a half-life of 120 minutes. Okay, it emits radiation at a rate of 100 particles per second. How long does it take for the rate of emission to fall to 25 particles per second? So if we draw the graph, this is 125, like this. So from a lot to like 1/4, from 100 to 1/4 of 100, which means that there's 2 half-lives being passed. And if they want the time taken, so 2 half-life is 100 into 2, 120 into 2, 240 minutes. So the time for 2 half-life is 240 minutes. Answer is D for 37. 38. Which rule correctly identifies the bodies P, Q, and R? So we can see that Q is orbiting P, which suggests that Q is a moon. P is orbiting R, so P is a planet. And if P is a planet, R is a star. So for 36, P being a planet, okay, between B and C, Q should be a moon. So B is the correct answer. 38 is B. Which statement about the sun is not correct? So they bolded the words not. You have to find something that's wrong about the star. The sun is one of the biggest stars. That is wrong because there are more stars that are bigger than the star. So 39 is A. 40. Which statement about the Milky Way galaxy is correct? It is the galaxy. It contains stars that are about the same distance from the Earth as the sun. That's not sure. We can't say. B. It is a collection of about 1,000 stars that can be seen from Earth. That's also wrong because Milky Way galaxy contains many stars, many planets, asteroids, everything. So B is also wrong. If they say it's a collection of solar systems, then that could be right. Number C, it is the galaxy that contains the sun and the earth. This is correct because this is a fact that we know. For D, its diameter is about 1 light year. That's wrong. There's a specific value for it, which is in the book. So 40 is C. C is the most correct one and the most certain one. So just choose that. 40 should be C. That is all for this paper. Thank you for listening.